wanted to give an example of each of these circuits in something you've probably seen in your day-to-day life. Holiday string lights. This, given it has more bulbs than before, is still a series circuit, right? One bulb connected to the next, to the next, to the next, to the next, through the whole circuit. I replaced our voltage source from before with a plug like you would plug into the wall, because that is just another type of voltage source. One of the takeaways of this, let's say one of your light bulbs burns out. And what happens when a light bulb burns out in one of these string lights? None of them turn on. The whole string stops working. Well, that's because they're connected in series. So when one of these is effectively removed from the circuit, there's no longer a circuit. There is no electrical connection here anymore, so they all stop working. That's why you have to replace this light before the string works again. On the other hand, you would have a parallel circuit. Say something you have in a like a ceiling light fixture that has multiple bulbs in it. Have you ever noticed that sometimes one bulb will die, but the other 2 or 3, they'll still be working fine? That's because those fixtures are wired in parallel. So you have power coming in, going through all these light bulbs, but they're all wired up in parallel. Now we take one out of the equation. One of them burns out. Well, these 3 are still plugged in. They're still connected to the source. They keep working. And then, eventually you get around to replacing this bulb, and then your 4th one works. But while the 4th one is in there, the other 3 still work. So there's just an example for you where you would have seen circuits like this and why you might choose one over the other. These are trade-offs you'll have to consider when you're designing something, but sometimes you'll use one topology, sometimes you use another, but in theory, they both work for both.